Okay, so what I want to do in this video is go over the solutions for practice 5B. So practice 5B solutions. Okay, so the first question, you're asked to multiply two monomials together, so negative 3 m to the fourth z to the fourth times 5 m to the fourth z squared. So remember how you do this, right? You multiply the coefficients together first, so negative 3 times positive 5 is a negative 15. Then you multiply the powers, right, the variables together using the product rule. So if I have m to the fourth times m to the fourth, then the rule is I keep my base, the m, right, because that's the same, keep the base, and I add the exponent. So 4 plus 4 would be 8. And then z to the fourth times z squared is going to be z to the 4 plus 2, which is 6. So that would be my result, which in this case is C. Okay, 2. We're asked to simplify this expression. So I have 5x plus 10x and then times 5x squared minus 6x minus 9 and then plus negative 8x plus 1. Okay, so what do I need to do first? Well, I better distribute in that positive 10x, right? So I need to distribute this into that expression. So I need to multiply all these. So this is going to be 5x, right? That stays the same. Plus, then 10x times 5x squared is 50. And then x times x squared is x cubed, right? Remember, x means x to the 1, right? So there's an implied 1 there. 10x times negative 6x. Well, 10 times negative 6, right? Do the coefficients first. That's negative 60. And then x times x, I have to add the exponents. Well, 1 plus 1 is 2. So this is just going to be x squared. And then 10x times negative 9. Well, 10 times negative 9 is negative 90. And I still have an x there. And then for the remaining polynomial, I can remove those parentheses, right? Because there's just a 1 in front. So I can write this as minus 8x plus 1. Okay, now I would combine like terms, right? So it looks like I only have one cubed term. So 50x cubed. I'll just cross that out and write it down again. Then squared terms, actually it looks like I only have one squared term as well. So negative 60x squared. But then x terms, linear terms, I have 5x minus 90x. So 5 minus 90 is negative 85. And then another negative 8x. So negative 85 minus 8 is going to be negative 93x. And then for constants, I still have that plus 1. So that would be my answer. So in this case, it looks like it's B would be the correct answer. Okay, 3. Actually, 3, they're just asking us to multiply these two binomials together. 5x plus 1, and then 4x minus 6. So remember, when you multiply a binomial times a binomial, you could use FOIL, but FOIL is nothing more than, the general technique of taking one term in the first polynomial and multiplying by every term in the second polynomial, and doing the same thing with the other term in the first polynomial and multiply it by every term in the second polynomial. If you use FOIL, then we're saying we're multiplying the first terms together, 5x times 4x. So that's going to be 20x squared. Then we're multiplying the outer terms together. So it's 5x times negative 6. So that's negative 30x. Then the inner terms together. So positive 1 times 4x is just positive 4x. and then the last terms together. 1 times negative 6 is minus 6. And then we can do one more thing, right? We can combine like terms. So negative 30x plus 4x, so that's gone, right? There's only one x squared term. But negative 30x plus 4x is negative 26x, and then minus 6. So that would be my answer. So in this case, it looks like B is the correct solution. Okay, 4. So here we have, so now actually you're multiplying a binomial times a trinomial, right? So think of them as just two general polynomials you're multiplying together. So 6p minus 1 and then times 36p squared plus 6p plus 1. So again, how do we do this? Well, each term in the first polynomial, so I'll start with the 6p. It's got to be multiplied by every term in the second polynomial. Then the negative 1 has to multiply by every term. So I'm going to end up with 6 terms, and then I can combine like terms to simplify it, right, if possible. Okay, so first thing is 6p times 36p squared. Well, that's going to be 6 times 36, right, which is, I guess, 216, right? So 216 p, and then p times p squared is p cubed. Then 6p times 6p is 36p squared, right? 6 times 6 is 36. P times p is p squared. And then finally, 6p times 1 is just 6p. Then I have negative 1 times 36p squared. That's a negative 36p squared. Negative 1 times positive 6p is a negative 6p. And then negative 1 times positive 1 is a negative 1. And if you look at this, many things cancel, right? The 36p squared and negative 36p squared, that's gone. Positive 6p minus 6p, that's gone. So I'm just left with 216p cubed and then minus 1, and that's it. So that would be my answer. So it looks like in this case it's going to be A. It's going to be the correct answer. Okay, 5. Let's start a new page for 5. It says determine a polynomial that represents the area of a square having sides of length s equals 2x minus 9y. So if we have a square here, right, what they're saying is that this length, which they're calling s, is also equal to 2x minus 9y. And in this length, which is also s, right, it's a square, so the length and width are exactly the same, or the sides are all equal. So this is also 2x minus 9y. So how do I find the area of a square in general? Well, it's going to be length times width, or in this case, side times side, which you can write as side squared. So since the length of the side is 2x minus 9y, to find the area, I really want to do 2x minus 9y squared. Now, there's a couple of ways you could do this, right? If you wanted to use one of those special products, remember we had, if you have a minus b squared, this is simply going to be equal to a squared minus 2ab plus b squared. So you could use that special product. Or the other way to do this, and I really think ultimately it's going to be just easier, unless you know those special products. If you like memorizing that and you find it quicker, that's fine. But an easier way is just write this out in general. 2x minus 9y squared means 2x minus 9y times itself, right? So now we can multiply those two polynomials together. And since they're binomials, you could use FOIL. Doesn't matter, it's really the same thing, right? I need to multiply the 2x by every term, and then the negative 9y by every term. So in this case, 2x times 2x is 4x squared. 2x times negative 9y is negative 18xy. Negative 9y times positive 2x is another negative 18x. I'll write it as xy. And then negative 9y times negative 9y is positive 81, right? 9 times 9, and then y squared. And then I can combine the two middle terms, right? The xy terms are like terms. And if I do that, I'm going to get, so that's gone. I'm going to get negative 18 minus another 18 is negative 36 xy, and then plus 81y squared. So that would be my final answer. So it looks like in this case, it's going to be B. Okay, 6. Actually, it's another one, a special case. In fact, it's the same exact form. Let me do it using the special case formula just to show you how you do it that way. So again, remember, right, if we have a minus b squared, that's equal to a squared minus 2ab plus b squared. So if I call the negative 3x my a, and the 11, just 11 by itself, b, then I could plug into that formula, right? So I have a squared minus 2 times a times b plus b squared. So I'm just plugging in to that to the right hand side of that equation. Right? For a, I'm plugging in negative 3x. For b, I'm plugging in 11. So now if we work this out, well, negative 3x times itself is positive 9x squared. I have minus 2 times negative 3 times positive 11. Well, negative 2 times negative 3 is positive 6 times 11 is 66. Right? Still have an x there. And then 11 times 11 is what? 121, right? So that would be my answer in this case. So it looks like it's D would be the correct answer. If you don't like using that formula, right, that the a minus b squared equals a squared minus 2ab plus b squared, then just multiply it out, right? Negative 3x minus 11 squared means negative 3x minus 11 times itself. So you could just multiply it out, FOIL it out like you normally would, and you'll get exactly the same answer. Okay, so if you don't like those special product, you can always just multiply it out. All right, now 7, actually remember, this is the one that I think it's worth remembering, the special product. Let me do a new page here. Just because it comes up a lot. So 5p plus 8 times 5p minus 8. Remember, there's a special product that says if you have a plus b times a minus b, this is equal to a squared minus b squared, right? The product of a sum and a difference is going to be equal to a squared minus b squared. So in this case, our a, right, would be 5p, our b would be 8. So I have a plus b times a minus b. So I know my result is going to be a squared minus b squared. Well, what's 5p squared? That's 25p squared. And then minus 8 squared, 8 times 8 is 64. So in this case, that's the one where I think it is worth memorizing because it's just really quick. However, if you don't want to, you could always just multiply it out and you will get exactly the same thing. You're going to find that the outer and inner terms, right, when you do 5p times negative 8 and then 8 times positive 5p, those are going to cancel. And you're always going to be left with just the first terms and the last terms. Okay, so 7 should be D. All right, 8. Oh, same thing, right? So I have m plus n times m minus n. So if I use that rule and I call m a and n I call b, this is going to be a, which is m squared, minus n squared, right? Minus b squared, but b is n in this case. And I'm done. So in that case, it's very quick. So that should be A. Okay, 9. Oh, actually, this one's similar too, although you have another term out front. So here we have x plus 2/7 x minus 2/7. Okay, so I would do this first. So leave the x cubed alone. We'll deal with that later. Do that first. Well, this is the same form, right? This is a plus b, a minus b. So this is going to be a squared, but a is x, right? So let me note that here. So a is like my x, b is like my 2/7, minus b, which is 2/7 squared. But then I still need to multiply that whole thing by x cubed later on. Okay. But what's 2/7 squared? Well, 2/7 squared, I'll do it on the side over here. You can think of that as just 2/7 times itself. Right? So this is equal to 4 over 49. Okay? Or, if you wanted to, you could also use the rule of exponents. This is raising a quotient to a power, right? You could also think of this as, remember, the numerator gets raised to the second power, and the denominator would also get raised to the second power. And again, you would get 4 over 49. Same thing, right? So either way, you're going to get 4 over 49. So then this becomes x cubed times x squared minus 4 over 49. And then I'd have to finish this up by distributing the x cubed. So x cubed times x squared is x to the 5th. And then x cubed times negative 4 over 49 is negative 4 49ths x cubed. And that would be my result. So that should be B. Okay, number 10. Let's see. As the temperature of a light bulb's filament changes from T1 to T2, the energy that the filament radiates changes by the quantity. Okay, so they give it as A times T1 minus T2 times T1 plus T2, and then times T1 squared plus T2 squared. Okay, so if we look at this carefully, right, isn't this right here, this product, these two factors, isn't that a minus b times a plus b? That's one of our special products, right? So this is just going to be, first of all, I have that little a that has to stay up front. Then this is going to be a squared, so T1 squared, minus b squared. And then I still have the second factor at the end here. Do you guys see what I did there? So T minus T2 times T1 plus T2, right? T1 minus T2 times T1 plus T2 is the same as A minus B times A plus B. Well, we know that result is going to be A squared minus B squared. So I thought of my T1 as being like my A, T2 as being my B, so I get T1 squared minus T2 squared. Now, if you look at this again, this is also our special case here, right? So it's T1 squared minus T2 squared times T1 squared plus T2 squared. That's A minus B times A plus B. Same thing, right? So now I need to do A, which is T1 squared minus B squared. Okay, and I still have a little a out front, so I'm going to make sure I keep that in track. Well, what's T1 squared? Well, I have to use the power rule, right? So remember, you multiply the exponents together. So you're going to get T1 to the 4th minus, and then this is also going to be T2 to the 4th. And then finally, I can distribute in that little a. So I'm going to end up with a times T1 to the 4th minus a times T2 to the 4th. So it should be, in this case, it should be A is our correct answer. Okay, 11. All right, divide and simplify. Okay, so we have just a monomial divided by a monomial, in this case, 8x to the 8th divided by negative 4x cubed. So remember how to handle this. Divide the coefficients. So 8 divided by negative 4 is negative 2. And then x to the 8 divided by x to the third, remember you subtract, right? You keep the base and you subtract the exponent. So 8 minus 3 is 5. So this should be negative 2x to the fifth, which is A. Okay, 12. I'm dividing a polynomial by a monomial. So I have negative 35x to the fifth minus 21 x to the fourth minus 28 x cubed all over negative 7x to the fourth. So remember, the first thing you have to do to handle this type of problem is rewrite it, right? So put each of those terms in a numerator over that monomial, which was in the denominator. So then this will be plus negative 21 x to the fourth over negative 7x to the fourth plus negative 28 x to the third over negative 7x to the fourth. Okay, so now we can simplify this, right? So what is negative 35 divided by negative 7? Well, that's going to be a positive 5. X to the fifth divided by x to the fourth. Remember, the rule is you subtract exponents. So 5 minus 4 is 1. So I just write this as x. Plus negative 21 over negative 7 is positive 3. And then x to the fourth over x to the fourth is x to the 0, but that's just 1. Or the other way to think about it is these are going to cancel, right, and give you a 1. And then finally, negative 28 divided by negative 7 is positive 4. And then x cubed divided by x to the fourth. Remember, we subtract the exponents. Remember, if I do 3 minus 4, that's a negative 1. So this is x to the negative 1. But then if I want to write this with no negative exponents, these two terms are fine. And here, in the last term, I'd have to put the x in the denominator, right? And then it becomes a positive 1, which we don't have to write the positive 1. So that would be the answer. In this case, it looks like it is B is the correct answer. Okay, 13 is similar. So negative 10x to the 8th minus 4x to the 7th minus 6x to the 5th minus 12x cubed all over negative 2x to the 5th. So again, rewrite, right? So this is going to be equal to negative 10x to the 8th over negative 2x to the 5th plus negative 4x to the 7th over negative 2x to the 5th plus negative 6x to the 5th over negative 2x to the 5th plus negative 12x cubed over negative 2x to the 5th. Okay, so now we can handle each of these separately. Right now, each term is just a monomial divided by a monomial. So negative 10 divided by negative 2 is positive 5. X to the 8th divided by x to the 5th, why I would subtract exponent, so 8 minus 5 is 3, so this is x cubed. Plus, negative 4 over negative 2 is 2. X to the 7th divided by x to the 5th is x squared. Plus, negative 6 over negative 2 is positive 3. And then x to the 5th divided by x to the 5th, they cancel, right? Or you could say x to the 0, which is 1, or they cancel and they give you 1, either way. And then plus negative 12 over negative 2 is positive 6. And then x cubed over x to the fifth is x. Remember, 3 minus 5 is negative 2. And if you want to rewrite this so that there's no negative exponents, these terms are all fine, except the last term here I'd have to write as 6 over x squared, right? I'd move the x variable to the denominator, and it changes the sign of the exponent. So it'd be 6 over x squared. So it looks like, in this case, A is the correct answer. All right, and then the last one, actually this is just a monomial divided by a monomial again, so negative x to the eighth y squared z to the fifth over x to the fifth y to the eighth z squared. Okay, so the negative I'm going to have to just keep, right? That's going to stay with me. X to the eighth divided by x to the fifth. Well, it's going to be x, and then I subtract the exponent. So 8 minus 5 is 3. Y squared divided by y to the eighth. Well, it's going to be y. Subtract the exponents. Well, what's 2 minus 8? Same as 2 plus a negative 8, right? So that's going to be negative 6. And then z to the fifth divided by z squared is z cubed, right? 5 minus 2 is also 3. And then we probably want our answer with no negative exponents. So I can fix this. Actually, the x cubed is fine in the numerator. The z cubed is fine in the numerator. I have to bring the y term down to the denominator, and then the exponent changes from a negative 6 to a positive 6, right? So that would be the answer, and it looks like it's D in this case. Okay, so that's it. Those were the solutions to practice 5B. Thanks.